Okay, and now we are live. So welcome to today's webinar to see how VRM Switzerland achieved the world's first EASA qualified virtual reality flight simulator with the Varjo XR3. And this have to be one of the most exciting things that has happened to the whole VR and XR industry this year. This is one of the things that proves that these technologies are right now coming to mainstream and they can be actually used for pilot training as effectively as any other previous technologies. So my name is Markus Heinonen. I'm your host today, and as my co-host today we have Fabi Riesen, the CEO of VRM Switzerland. Fabi, congratulations again for getting the qualification, and thank you for joining us today.
Thanks for having me on the show.
Thanks. And as a second co-host today, we have Claude Bouchard, a pilot and a president of the Bouchard Recovery Aviation Safety Foundation. And Claude, thank you for joining us today.
Hello, everybody. I'm from Fribourg, Switzerland, and nice to have you on board.
And for people watching this right now, many of them might not know what is the Bouchard recovery technique. So can you just tell us in a few words what that means and why it is so important in aviation safety that you wanted to found this safety foundation for it?
It's a phenomenon when the helicopter is on down wash, is a recirculation possible under certain condition, and with full power we are descending with 3,000 to 7,000 feet per minute, and that means more than 10 blocks per second. And so you need to escape, and to escape I developed the technique. Of course, there was an old technique, but I developed the technique to you're using the tie rotor crossing controls and you are out in a second. So you are safe if you are getting that. It's what I developed. Was took over by the FAA, was took over by Robinson Helicopter, and now it's spreading like the corona around the world, but with a better. Okay.
That's very, very exciting and important point, and hopefully we can also train for that in virtual reality, right? Maybe right now or in the future. And without further ado, let's get into our topic of today, which is virtual reality. And before we get into that, just a quick note about questions. So you can submit your questions anytime during the presentation with the Q&A tool, and then we will take the time at the end of the presentation to answer all of them at once. And a quick reminder on those of you who might not know, with Varjo, we are the enterprise grade virtual and mixed reality headsets that has the highest resolution out there on the market that allows you to see details as clearly as you see them in real life. Varjo is founded in Finland. We're right now around 140 people based in Helsinki, but we also have offices in the US and selling to 40 markets. And today we will be focusing on the virtual reality and how that can be used to train pilots. And if we will go back to a few years, and Fabi, if you could start by describing how did you really get into VR and how this whole thing started for you?
Yeah, so I mean, simulation was already a passion for a while. I mean, back in 1998, where we flew our first train simulator. Then back in 2013 and 14, we've realized that there is a new technology coming out, which is was very promising to let me say, to fill the gap of something which was always there. I will go more in detail afterwards to that, but filling the gap in the visualization, not having a 3D visual. And this is where we started to experiment with the first early prototypes. You see kind of like one SDK, which is almost like history. Then back in 2015, we believed that we should investigate much more, and did many researches where the discussion was kind of like how to bring the virtual reality, which brings us the 3D visual, together with the human body. I mean, there are many things I'm sure you are aware of. You don't see your own body. You cannot operate cockpits. People get sick, and so on. And one of those studies back in 2015 was kind of like, which flight simulation software is going to be the right software to scale in future. What we meant at the time there to scale in future is once we have VR glasses, head-mounted displays available, like what we have today with the VR3 from Varjo. And there we ended up on a very special thing for the time being on IPEX, and this is where we were able to make a partnership with IPEX. IPEX makes fantastic flight simulator games for mobile phones as well on desktop, and we've been able to get the commercial license, the exclusive right for the commercial license to build flight simulators using the entire framework from IPEX. The specialty there is it has its own graphic engine, which allows us to modify anything in the whole visual queue, and also its own physics engine. Then a little bit later, the next slide, we showed kind of like a test balloon, let's call it a test balloon, FA-18 fighter at the ITEC trade show, where we had virtual reality almost working with a motion platform. And then in 2018, there was kind of like the gigantic step where we found a very important use case worth to solve, a real problem worth to solve with the technology. And I mean, it's obvious we have helicopter experts here with us, with Claude Vuchard. It is in the helicopter market. And it was just a good moment from a timing point of view, because in 2018, EASA, that's the European Aviation Authority, also came out with the rotorcraft safety roadmap. And within the rotorcraft safety roadmap, they identified the gaps and on the amount of accidents which are still there and so on. And one of the important gaps is to have realistic and affordable flight simulators for smaller helicopters. So it's just kind of like right moment. And this was also the year where we started to work directly with real operators and flight schools, because it's always like if you develop something and then you just kind of like try and sell it, it's not going to work. And here we were lucky to have Ersamat on board, the Heli Academy as well, the mountain flyers. It's kind of like a little bit a mixed shop, more like fly school and also helicopter operation. But it was broad enough to start. And in 2019, we signed a partnership with EASA with the goal to see kind of like how can we qualify such a device. This was, by the way, also the year where we signed the first letter of intent with Copter to develop for Copter. That's the SH09. Now it's the AW09 of Leonardo to build the flight simulators for that device. Then in 2020, you see kind of like it's a little bit hidden, but this was the year where we had a lot of time because everything was silent. And this was also the year where we managed to get the approval from the EASA side for applying for the qualification, which now has been reached beginning of this year.
Oh, so can you say a few words what it means to be qualified by EASA as a flight training solution?
Yeah, this is a very good question. Basically, what it means is if you build a flight simulator, I mean, everyone can use it, and you can play with it, you can train on it. But if you want to use it for training, it needs to meet very specific standards for various reasons. First of all, to assure that we achieve the training subject there, and second, also to assure that there is no negative training made. Negative training means that you kind of like train something on the simulator, and at the end your muscle memory is programmed for it, and if you do it on the right helicopter, you may can even die. And from that point of view, there is a huge regulation work, and this is what we kind of like went through, and because that huge regulation work is not aware about that type of technology, we had to go through very, very many different special steps. And at the end, if you can qualify the simulator in the professional, what is called the FSTD, Flight Simulator Training Device, if you can qualify it, you can log the hours in the logbook as a pilot. So it counts towards your logbook, which means a lot, because like in your basic education, you may can do 5 hours or 5 hours on the simulator instead on the real helicopter. And as you know, a helicopter is not really cheap. So it is also having an interesting financial aspect. But first of all, always in the middle, it has a very good impact on the safety, because many things you cannot do on the real helicopter, but you should train.
Yeah, and you mentioned that you met with Claude in 2018. So maybe a question for you, Claude. What made you get interested in VR training specifically, and why you decided to start a collaboration with VRM?
I had the idea to improve the safety, of course, what I'm doing in all the aviation sector. I had the idea to see the market of the VR technology was growing, and was searching for somebody who is developing, and I had contact with several manufacturers, and at the end, I found by chance the contact came to Fabi by a friend of mine, and I must say something. That was my first contact with the VR technology, and today I'm amazed what this VR HDM technology, how we developed, like your goggles, was developed for gamers, and now it becomes a game changer in the helicopter industry, and that is amazing. And I had this idea in 2017, 18. I was searching for somebody, and sometimes you met people and you are like this, and it's amazing what VRM Switzerland has brought on the market now. And that's, for me, it's a game changer. It was made for gamer, but now it's a game changer in the aviation, and I'm sure not only in the helicopter segment, but in the whole aviation. It's a game changer for safety.
For sure. And also EASA, the European Union Aviation Safety Agency, has been pushing this forward quite heavily throughout the past recent years. So perhaps can you describe some of the reasons why EASA is now promoting VR so heavily?
Yeah,
yes.
I mean, if you can see the numbers of civil rotorcraft aircrafts here, I mean, the European area is almost same size like US, so it's pretty large. And in the rotorcraft safety roadmap, they did the analysis on the accidents, and I mean, Claude, if I remember correctly, we still have one serious accident per week in the European area.
Yes, and one fatal accident per month. And what we saw also that all what we have implemented until today, we didn't change really the number of accidents. I'm sure that with the implementation of this VR technology, of this new simulator, it will be a big decrease in the accident rate soon.
Why is it especially those models listed here that has far more accidents than some of the other models?
Yeah, so first of all, those are the smaller helicopters, and meaning it's not so expensive to fly. Then if you keep in mind that a flight simulator, full dome flight simulator is a thing from several $1 million or Swiss francs or euros, and the helicopter is less, then it's obvious that there is no financial reason to afford a simulator for it. So it's cheaper to have a good assurance and to replace the burned aircraft afterwards. Apologize for saying it so hard, but if it's business-wise, not worth to do. And then the other thing is also the helicopters you see here, listed. I mean, those are where the people train, so the less experienced pilot. So exactly there where you should have simulators. They are simply not existing, or if they exist on a very bad quality level. And this is something which has been analyzed, and then the very last thing on that rotorcraft safety roadmap, which is also interesting, a lot of accidents are happening during training. So you train to be safe and you have an accident. I give you the example, and we see that later as well on the auto rotation. So if you have an engine failure, you can bring the helicopter still safely down, but that needs to be trained. And then if you have a full dome simulator where the terrain is unsharpened and you need to exercise it, you simply can't do it. So you cannot train it, meaning you have to train it on the real helicopter, meaning you train something you should not really do there.
Yeah, and I assume there are many other aspects that you cannot train with the traditional ways of training. So can you elaborate a bit more? Why did you choose to take the training to virtual reality specifically?
Yeah, sure. What I mentioned is kind of like the 3D visual. I will show that a little bit later. Then also the lighting, the shadows, the coloring, which are a lot of small details you don't have in a traditional simulator. And then, I mean, at the end, if this everything works nicely together, it also needs to be, a part of the training needs to make sense for the pilots. So it needs to be realistic, but it also needs to be affordable. And that you can get the credits for your flight hours. And that's kind of like where the combination of having a VR, let's say a full flight simulator based on virtual reality, combined with a qualification certified. That's basically the goal in the whole setup. I mean, we can quickly dive in. If you go to the next slide, it is very nicely shown. So what you see on the right side of this slide is this is how it looks like in a full dome simulator. Those are those simulators with gigantic dome projection. It looks very realistic and nice. You have a real cockpit. And then you can move your head from the left to the right, and this is how it looks like. So the picture is projected in a dome, and if you have mirrors to watch down, they are represented by a monitor, by a screen. So it's basically there. But if you look on the left side, this is how it looks like in virtual reality. In virtual reality, we have the nice thing that if I'm moving the head, the 3D visual is there. So like this concrete bucket is moving a little bit in front of the building if I'm moving my head. If I'm moving my head, as you can see as well, the mirror is correctly also reflecting what is seen in the mirror, depending on the head movement. Then the very last thing, which is also not possible in a full fly simulator with a dome projection, is having small details like this little trim string. We will see that in a later video as well. That's a little string giving you the direction, and it's glowed. You can mention it afterwards if you see it. It's very relevant also from realizing certain conditions whilst flying. And the helicopter pilot is exactly working close to the ground in those areas where we have in a full dome simulator not the correct vision, meaning the people have to learn to fly the simulator instead of to train on the simulator to fly realistic.
And then there are also some of the aspects that you just cannot simulate in a standard dome projection. So can you tell us a little bit more about that?
Yeah, that's an important point, and I maybe will also spend a few words on the mixed reality, if it's okay, more like to clarify where it is. So on the left side again, the entire picture is generated synthetic. It's kind of like you see it in virtual reality, and you can do all the shadows, the correct reflections. So the sunrise, sunset things, which are also nicely done with the cockpit. In a dome project, in a dome simulator, you don't have those effects. I mean, of course, you can dim the lights, but those things are simply missing. And you can also not you also cannot do too many combinations in that area by extra lights, because you have a projection in front. And most of you seeing the advertisement that we got qualified, as you they mostly realized that on the picture we do have the mixed reality version of the Varjo 3. Actually, the qualification is based on virtual reality only. We do not use any mixed reality features. I will quickly explain you that. The reason we've been using that VR glasses is not to confuse everyone. We really apologize that. It was simply the availability on the timeline. The mixed reality glasses was the first out. So the mixed reality is mixing the cockpit by filming it and having the synthetic picture done from the environment only. It makes it very simple for prototyping. It makes it very simple because you don't need to take care for all the body motions and so on, and you can just use the existing components. But one of the big challenges with mixed reality is like you are filming the cockpit, and the cameras, they are mounted in front of the VR glasses. And that means they are taking the picture not from the same position where your eyes are. That said, the perspective is not correct. It is fine if it's kind of like in a shorter range from your visual view, but going to the edge, there is a geometric distortion just based on the geometry. And in addition, if you film the instruments, it is not having the correct contrast of the colors and so on. And with that, even if I need to admit, I mean, the MR3 is by far the best mixed reality solution ever saw and ever I was able to try out by myself. But with that, it is simply not possible to meet the regulation requirements.
Exactly. So you have to choose the right product, right tools for the job, and in this case, you need that freedom of modifying that virtual environment only, and it makes things more simpler when you have only the virtual environment that you have to modify, not adding the video pass through there on top of it, and we'll get to that a bit later, how you then achieved all the haptics and the other benefits that typically is only possible with the mixed reality headset. But then if we think about the versatility of the VR devices, can you say a few words about when you compare that to the dome? What are some of the aspects that is perhaps not possible to do with the dome simulator?
I can tell that because I'm former air Zermatt pilot. It's in the heliport in Zermatt. Of course, with the normal dome projection, you cannot do vertical references. You even see the cleaning lady down the simulator, but you cannot see the load. And with the VR technology, even both are working very well. The mirror, so you can even adjust the mirror. It's not the monitor who moves. So you can adjust to have always the load centered. Even you have 10, 20, 30, 50, or 100 meters, you can adjust the mirror. And of course, that it's the big advantage. And the big advantage too is that you have really the feeling of the load when you're like it's real. And now you're looking on the right side to look the load. You cannot do that in a dome projection. It's not possible at all. So for training, for HESLO training or sling load training, it's impossible to do that in a dome projection but with the VR technology, look at this, you feel everything, you see, it's really real. Huh? I must say that the Varjo goggles are so sharp that you are immediately in a full immersion. That it's amazing. Even if you look out of the windows when you fly over the Matterhorn, if you have a fear of heights, you may treat the people because it's so sharp. And I was so impressed when we changed from the older model they had goggles and we moved to this one. But it's amazing. You can change easily from the bubble window. You can have the large window. You can have the maximum pilot view kit without any modification of the simulator. It's just by a click because everything is virtual. And that's, for me, is the future. The dome projection is not made for this kind of operation. It's not, no way. The future is in the VR technology. The dome projection is for a lot of things because you are missing the 3D. And that is, for me, the most important thing. Without any 3D, you cannot do properly training close to the ground with load and everything. That is really the change in all to do efficient training in all the field, not only on the air, but also on the HESLO, heli-hoist later on, whatever you can implement this technology. And that is the big difference for me. It's really a jump in the technology.
Cool. So on the next slide, Markus, we do have a very nice summary on the game changer Claude dimension. So first of all, because the VR glasses, you don't need the dome projection anymore, and in addition, it adds the 3D visual. On top of that, the weight from the cabin and the weight which needs to be moved is not so heavy anymore. I mean, as you can see on the device below. So we can move the platform in a much faster speed than what you can do with a large simulator. So like that brings us to the point where like full dome simulators, they are at the roll rate between 20 and 25 degrees per second velocity. We can go up to 5 times higher, which is very close to the real helicopter. So we are out of a sudden, a part of having a sharp ground, we can also do exercises which were not possible before. Then the footprint, you don't need a fabric hull anymore. You can really place it in the hangar. Like for example, the simulator for Mer Zermatt is just in front of the office of Georg Piemer. Then there is no PC farm needed anymore. I mean, we have one simple rack, and with the possibility of the affordability and the size and the fabric hall and so on, we increase the accessibility and the availability for safety training. There is no need anymore to travel once per year to a specific location, where already the travel expenses are much higher than what actually would be to fly it on the real helicopter. So it's kind of like, I mean, it's pretty obvious, but yeah, a few things to be fixed that you can get the whole thing working.
And I think also, as you mentioned, for me, it's very important that it's close to your base, because otherwise you go once in or every 6 months to a simulator. You learn just for 1 week, you learn to fly the simulator, you go back. And with that, it's very important. So you have really close to your base. You can go after 1 month back if you are not sure for certain procedure, and that is perfect.
And here we can see the whole thing in action, and this is how much space it takes. And then there's also the window that shows the pilot's view in the simulator. So Claude, perhaps you could say a few words. How was the first experience when you tested this simulator for the first time?
For the first time, I was impressed the first time already. But when I did all the tests after the certification, which I also published in a video, I was really impressed, because when we did, for example, the altitude test, when we flew at 4,000 meters, 14,000 feet, we noticed that I was increasing my breathing rate like in the real aircraft. You can imagine that I was still in Zurich on ground, but when I looked on the picture, I was in the full immersion. I was in the mountain at 40,000 feet, and my breathing rate, you can look it on the video, was increasing only by seeing the picture. You can imagine what immersion you are. And also, of course, for the auto rotation, for everything, for me, it's like the real aircraft. It's so, and you can really train. When you are doing training with a flight instructor on the helicopter, he has 2 safety barriers. One, he can cry, and the second, he can take the controls. But you're still in a narrow band of training, because you don't want to go in the dangerous part. And in the simulator, you may let go the RPM lower than what is described and you see what happens. So the field of training, you're increasing the field of training, and after, at the end, you set up as when you are the pilot, you learn, oh, I cannot go beyond this because this will happen, and you will never see it in a normal operation. And for me, again, is the fully immersion with the 3D and the sharpness. It's for me the paramount things if you want really to cheat pilot, because otherwise you would never have that. With that, you are really in a full immersion, and after, of course, with the motion too, and also with the very fast motion, as Fabi mentioned, you really are inside. You are really in the aircraft. I was in Zurich at 2,000 feet, 4,400 feet, and my breathing rate was for 14,000 feet. So just to explain you a little bit what means good goggles.
That's amazing, and the immersion. It's not just simulation; it's a real experience when you get your heart racing.
I really appreciate, Claude, and happy to hear you are now excited. For all the guys and gentlemen and women on the call, it was not really easy to convince Claude on all the things. He gave us a really hard time. It's kind of like selling a tennis racket to Roger Federer. So let me go quickly to the challenges we had to solve here. I mean, one thing is, as you could see, the platform is quite dynamic, and it is actually meeting the full flight simulator level B qualification with a reduced stroke. That said, it is not just kind of like a motion platform with 6 degrees of freedom, which is there and in a qualified device, and if they don't like it, you can turn it off. It is actually really qualified to meet those specifications. Quite some difference to other simulator types. Given it is moving so fast, it is very difficult for the headset to know whether the pilot is watching straight. So if the pilot is watching straight, you should not move the picture. But there is this headset tracking, so that needs what is called motion compensation. That's something where the motion from the motion platform needs to be subtracted from the head movement. And this needs to be done on picture exactness. So this was one of our big challenges. So we had to really go deep into the graphic engine. It's our own graphic engine. Because if you just use the standard trackers and you do the diff signals, you will not meet the specifications from a qualification point of view. Then a very challenging thing, how can we operate the cockpit? I will show that afterwards to you. This just plays in the other one on the multi-crew. I mean, how can you do multi-crew, I think? And then, of course, a lot of investigation in the cyber sickness prevention by having our own motion queuing algorithm with many small details, which are kind of like optimizing to have a very broad range of people feeling well on the simulator.
So how is the cyber sickness when compared to the dome projection, for example? What is the perhaps Claude, the pilot's view on this when compared to the traditional ways of training?
Yeah, it's a good question. Claude won't be able to answer it. You can hang him on 1 feet under a helicopter and fly for 10 hours. He will not feel sick. That's a little bit of a challenge. Based on research together with the university, we had access to a huge amount of people, and we made those A and B group testing and so on. So this gave us the possibility to optimize it. So if you compare it afterwards to the full flight simulator, we actually had people, pilots, experienced pilots, which did mention that they will get sick after 5 minutes, they will get sick after 8 minutes and so on, and we compared to that. And we were happy that there was, for example, one pilot who was very clear that after 8 minutes he gets sick on the simulator, that this pilot was also after 2 hours on the simulator still feeling okay. The factors where you really can make sure that people will get sick is that you have a bad motion compensation, meaning every product which is not having access to the graphic engine and is doing motion compensation, you will have people getting sick. And then the other thing is that if you have a motion platform which is not doing exactly what it should do, from the motion queuing algorithm. They are kind of like two very important things, and more brilliant the picture goes, more sensitive people will be. So this is I mean, it's always kind of like, oh, it would be nice to have higher resolution, but then it's kind of like, oh, out of a sudden they realize that things are moving. And then the very last thing is having a picture frame rate. So if you're not able to run the frame rate, to maintain the frame rate, and you have glitches, people can will get immediately sick because they don't have any reference anymore to that.
Yeah, that's very, very interesting. And perhaps we could look at some of the other technical aspects that need to be put together in order to achieve this level of immersion in the copy. So if you could, Fabi, just very quickly walk through the individual pieces, and then we can look at the videos of this in action.
Sure, yeah. So one thing you've realized is that the instructor is not co-located anymore on the simulator with the pilot. And still, I mean, how can you teach a young person never flying a helicopter before? With that, we had to build our own control loading system, which is super optimized for such things and very precise. So those things also need to work with friction and so on. So we have a dedicated system where we can simulate the friction. And basically, the fly assistant from the whole system is allowing to teach the student on the helicopter. And the student will feel if the fly assistant is going to help. And we can do that in a very consistent manner. So like on a real helicopter, the student can first kind of like just learn with one axis and the rest is done by the fly assistant. Then the other part is the physics model, I mean, how the helicopter behaves. Here we had to build our own flight data set because with new things which are now possible on the simulator, in certain areas there were missing flight data. I give you the example, out of a sudden you can fly close to the ground and you can do external sling load operation by vertical reference flying. So we built our own flight data logger and we made a flight test campaign to record flight data to measure also the load, how it behaves and the helicopter is behaving. Then in order to operate the cockpit, we will come to that with our human post tracking. And then last but not least, each machine needs to be calibrated, including the visual system from the beginning to the end. And the machine needs to be, if it's qualified in a thing, that it needs to be recalibrated if things are changing, if it's if it's a qualified, certified machine. And with this approach, a lot of things we had to do there. So we thanks to having the production also in-house, we can do the whole chain, we can measure the whole chain and we can optimize the whole chain there.
So here is also representation of all of the different things that go into it, and because of the complexity, you wanted to do it with your own graphics engine, you wanted to do your own physical simulation. So can you describe a little bit more about that process and how it comes together?
Yeah, I mean, that's thanks to the fantastic partnership we do have with IPAX. I mean, here you see very nice that trim string. That's this little string, this thread in front of the window. I mean, something you cannot do in a full flight simulator. Maybe Claude, you can quickly mention for what it is used as a helicopter pilot.
Yes, it's a very important indication. I call that the volometer, because it's from wall, but it's showing once the volometer is collapsing, we are already may enter in a vortex ring dangerous area if other two conditions are met. As you see also if the wind is coming from the right, from the left, and as long as it is active, that means that we have the deflection on the main rotor, and the main rotor downwash is not anymore 90 degrees to the rotor disc, what is the condition for the vortex. But it's a very, very important instrument also. You can fly, and it's well simulated. I must say it's real. I have the impression that they put the wall on in the goggles to cheat me, but it's so real that I cannot almost not imagine how many computation you need per second to make the modulation of this volometer.
Yeah, and then Marcus, a part of those things, I mean, it's written here, kind of like the physics simulation is running at a very high frequency. I mean, it's 1,000 iterations per second to calculate it. That's kind of like what's needed. It's a numeric kinematic simulation and validated by real flight data. And this is playing together with the graphic engine. And I mean, I already saw a few questions on chat here. So the graphic engine and the physics engine is our own. It is an enhanced version of what you have in from IPAX in Aerofly. and it is tuned with our own flight data on the physics engine and the graphic engine as well. So really everything, let me say, handmade, and thanks to that, we've been able kind of like to do all the right calibrations needed for the EASA qualification.
Perhaps we could then also look at the how did you do the mapping with the physical world with the virtual world, because you decided to go with a full VR simulator, but then you still have that haptic feedback. So maybe we can still look at this before we go into the questions then here.
Yeah. I mean, at the end, if in the simulator world from the devices, there is the term a full-scale replica cockpit. Full-scale replica means that the geometric dimension are the same, the feeling and the haptic is the same. And the way we've achieved that is we've just built the cockpit in real, and we developed a system which is called the human pose tracking. And the human pose tracking is scanning the entire person in real time. And by scanning the entire person in real time, it creates a skeleton, and that skeleton is animating the avatar in virtual reality. So what we have is in real time, a avatar which is doing exactly the same movement like the pilot is doing. And this is working on the high dynamic motion platform, and it is working with a latency which is not noticeable for the pilot. And it is working in an exactness that every single switch and button is found without trying around with the hands to find it. And that was kind of like, I think, the most challenging thing to solve. I mean, with virtual reality, we add the 3D visual, we add all the correct shadowing, lightening, and so on. But we kind of lose the human body. And with this solution, we maintain the geometric distortion. Is correct. I mean, there is no distortion. It is correct. We maintain the geometric thing, which is a requirement for the qualification, and that's also the reason why mixed reality is not possible to qualify. I mean, you have a very gigantic distortion in the edges there. And here we also have the haptic back, and we can do it. And now the very nice thing is, with that approach, by combining the Varjo glasses with that human pose tracking we've developed in-house, we kind of like have everything digitized, every movement, the avatar, and so on. So like the pilot sees him or herself as a moving avatar in the VR glasses. And the same information is also sent to the instructor station, meaning the instructor can sit on the instructor seat and can watch around, and he sees every single movement, you can wink and so on. Given that we can now show it on the own simulation computer and on the instructor computer, we can show that avatar also on a second or third simulator. And with that, we basically enable the entire system for multi-crew. So here we can now exchange that information in virtual reality. It can be even in separate rooms. So it's an already COVID social distancing approved solution also for the future.
That's very interesting, and so many different technical pieces that has to come together. And also you have had to work with the authorities, the operators, and also here with Claude, with pilots getting the feedback. So it must be a very complex system to manage. But here, perhaps for the interest of time, we could skip right into our Q&A, because we've seen that there are questions coming, perhaps more that we can even answer today. But let's start. Here's a question from anonymous attendee. Exactly what means the EASA approved for training? I think we touched on that in the beginning.
Yeah, I mean, as I mentioned, like for the basic training, you can do a couple of hours on the simulator, and they count towards your private pilot license. And we also announced the Squirrel. I mean, that's the H125. On this machine, you can do your operation checking or the proficiency checking, something you need to do every year and every half year. So this is basically counting to be done on the simulator. First of all, in a safe way, but second also, I mean, it's also cost discussion. Then on the next one, the FAA approved. I mean, in Europe we have EASA. In US we have FAA, and there are many others. So the good news is, yes, we already work with FAA, and we just signed yesterday the first contract for the first Squirrel H125 simulator in US. So stay tuned. Ready to order now. So that's this is something which is definitely going on. And I also need to admit, it is amazing how the authorities are working together. It is amazing how the authorities are open for new things. As long as we keep the safety in the focus, it is all possible. The moment you go there and you just want to push something, I mean, there were people saying, yeah, EASA is qualifying mixed reality. I mean, that's garbage. It's not EASA is qualifying. EASA is qualifying a simulator. If someone provides a simulator with virtual reality technology, then everything, the whole device is getting checked because it needs to fulfill a safety aspect, a training aspect. And as long as the authorities approach with that and we meet those requirements, it will work fine.
Yeah. Then there is also a question for Claude. Do you, the pilots, wish the field of view with high resolution was wider? What do you think about the current training devices, and is there a specific wish list perhaps for you, what you would like to see more of in the future?
Of course, as a helicopter safety expert, and after I did the test on the VRM Switzerland simulator, I welcome such development overall. So of course, in particular, I think I would like to see more helicopters CS FAR 27, that is the light segment below 7,000 pounds, or what is 3,125 kilos, 175 kilos, sorry. And of course, I would also like to see other developments like the interaction with the crew for heli hoist. That is very important too. For me, of course, the field of view, that is clear. The more you have, better will be for other operation. That is clear. For the basic training, for me, it's okay today. It's nice. The training is very efficient. You have no negative training at all. And even, but in the future, I think also developments on your side, of course, more field of view will be better for certain operation. That is a fact. But anyhow, it's a big game changer, an improvement in safety, that actually what we have is good, and we probably go to perfect even more in the future. But today, for me, if you do that training, my son wants to start to fly. I told him, you fly first VRM Switzerland simulator 20, 30 hours before you touch a helicopter, because my son is very important for me. That's my end of message.
Definitely. And that is exactly why training needs to be done in a safe environment. There's also a question about how long is the typical training session with VR?
Of course, Yes, when you look at your normal training session, when you are in the PPL, you should not be more than 1 hour in the beginning because you get tired. It's for me more or less the same. Of course, I'm used to, I flew 2 hours in the VR simulator for tests or more. With many things happened, of course, and I cannot compare me to a trainee who starts initially or they start the training. It should, for me, it's the same on the VRM simulator and on the aircraft when you're at the same level of experience. When you're higher, because the fact is the end, when you're doing aerial work, HESLO, you are sitting inside for 2.5 hours, 4 hours, 5 hours, 7 hours, doing 160 cycle of rotation, and you will have the fatigue. So I think it's also important because the price is less, you can also train the fatigue on the rotation, on the cycles, to do 2 hour cycles with load. That is important too. But anyhow, from the beginning, a low time pilot is the same like in the helicopter. He has the same fatigue, in my point of view.
Right. Then a question for Fabi. I think it just disappeared, but will VRM be exhibiting at ITSEC this year? I think many people are interested in testing out this device themselves. Will you be there?
Yeah. Unfortunately not. We will be at the Euro Tours at this time, and we do have a lot of deployments scheduled. You can imagine after the announcement, we just filled up our books, so we are quite busy at the beginning of next year already with shipping, installing, and qualifying the devices. So yeah, but I mean, if you cross Zurich in Switzerland, happy to welcome you here to try out one of the test machines or the one on the FSTDO one floor below.
And you need to go to Zurich because I want one in my garage in Fribourg. And Fabi don't want to give me one, but anyhow, so you need to go to Zurich, but even Fribourg is a very nice city where you see in my back. And, okay.
Yeah, and then there is, we can perhaps have 1 or 2 more questions. Maybe a quick answer to this one. Which aspects of the technology were the most difficult to prove the FSTD equivalent for EASA? HMD visuals, motion-based cockpit. Any specific?
All of above. I mean, look, I mean, every part in itself is difficult, but the biggest challenge is to have everything working together. Because, as I mentioned before, it's not like qualifying virtual reality. We are qualifying let me make this example. We are qualifying a full-scale replica cockpit, which is kind of like half there for the haptic, and the other half is there visually. And this needs to be synchronized from end to end. And at the end, you need to measure it to prove it, that it is correct and that it is full scale. And that's basically the challenge. So like building the machine that it works is, let me say, the easy part. But then proving and measure that it works according to specification from the regulation, that's a quite hard part. And then even harder is build a machine you can bring to a customer and make sure that it remains qualified the moment it's there. So, I mean, think about it, you cannot ask the customer to have a machine and to do every quarterly year a full QTG, and they need devices for that, which costs $500,000 or something like that. So that's kind of like one of the most difficult part to prove it.
Yeah, and I think we are now running out of time. Thank you so much for all of the questions. Unfortunately, we don't have time to answer all of them. There's still over 70 questions unanswered here, but if you wish to learn more about VRM Switzerland, you can go to their webpage or contact at info@vrmmotion.ch. If you want to hear more about the Bouchard recovery technique, go to Bouchard Recovery Foundation's webpage, and you can see all of the details related to that one, and more about various devices. You can reach us at sales@varjo.com or our webpage. But Fabi and Claude, thank you so much for this interesting discussion, and definitely one of the, if not the most interesting projects in the whole VR/XR industry this year.
Thanks a lot,
Marcus. Thank you, Fabi. Thank you.
Thank you.
And hope to see you soon, not virtual, but in real.
Yes.